Hello students. So now we are going to understand about the conservation of momentum. If there is no external force acting on an object, in that case, what exactly that results? Even there is an object that is moving, if it collides with any other object, in that case, as a result as well, the objects will move. Though there are going to be two different cases, one is going to be known as an elastic collision, other one is going to be known as an inelastic collision. So let's try to understand more about this in this particular topic, conservation of momentum. So what does basically conservation of momentum stand for? So when we talk about the conservation of momentum, momentum we discussed is basically the product of mass and velocity. So if I take two masses moving with different velocities, let's say UA and UB respectively, in that case this can be the condition before collision. So when this is the condition before collision, so we can say that the momentum of the ball A before collision can be given by MA into UA, and the momentum of the ball B before collision can be given by MB into UB. So this is the condition before collision. So this is something that happens. In between, when the collision is taking place, will be the condition, and after the collision has taken place, this will be the condition. So this is the condition for an elastic collision. So two objects come and collide with each other. After the collision, they separate out and move with different velocities. In this case, if you have to find out the momentum of the balls before and after the collision, so it's going to be MA into VA and MB into VB respectively. Taking this further, if you have to find out the rate of change of momentum, so the rate of change of momentum of the ball A, that will be given by this. So VA minus UA, so this will be the change in velocity divided by the time taken. Similarly, the rate of change of momentum of the ball B is going to be given by MB, VB minus UB divided by time t. So this is the change in velocity over the time taken. Now, here there is no external force acting. So whatever is the change in the momentum of the ball A, that is going to be equal to the change in the momentum of the ball B, but in an opposite direction. So this is the change in momentum of the ball A. This is equal to negative of the change in the momentum of the ball B, since there is no external force acting on this system. So if we just rearrange it, get rid of the factor of time t, because this is going to be taking place at a particular time interval. So I can write it as MA into VA minus MA into UA. This is going to be equals to MBUB minus MBVB. So if I just rearrange this, so rearranging this, I can write it as MAUA plus MBUB. So this is what is the initial momentum of the particles or the objects, and this is going to be the final momentum of the objects. So the initial total momentum is equal to the final total momentum. This is going to be possible if there is no external force acting on the system. The momentum before collision is equal to the momentum after collision. This thing is what is known as the conservation of momentum, or to be precise, linear momentum. Taking it further, if we say that after the collision, the balls stick together, or the two bodies stick together, so they move together with one uniform velocity v, let's say. So this is the uniform velocity v that they are moving about. So instead of the previous case where we had two different values of velocity finally, in this case, there is just going to be one single value of velocity v. So MAUA plus MBUB. So this is the initial momentum that is going to remain as is. This is going to be the final value of momentum that we'll get. So this is the case of an inelastic collision. In this case, you can find out the final velocity. So the final velocity is going to come out to be this. Though here there is not going to be a conservation of energy, there is going to be a loss in energy taking place when it is an inelastic collision. There is going to be no loss in energy if we take the case of an elastic collision. Clear? Okay. Now let's do some examples. Two examples to be precise. Let's say that you have a girl of mass 40 kilograms having a velocity 2 meters per second who is jumping on a stationary cart of mass 4 kilograms. As you can see, the girl is jumping on the cart, so obviously finally it's going to be an inelastic collision because both of them would be moving at the same rate. So using this, what will we get? We'll get MAUA plus MBUB. So this is the initial total momentum, and that is going to give you the final total momentum. Using this, we can find out the velocity with which both of them would be moving together, that is this value. So just putting in the values should give you the answer as this. Similarly, if we do a kind of a bullet and a gun problem, So if I say that the bullet of a mass 25 grams is fired with a velocity of 125 meter per second from a pistol of this much, as you can see there is no external force acting. So as soon as the bullet moves in the rightward direction, there is going to be a recoil that is going to be felt by the gun. So what will we have? We'll say that MA into UA, so that is this, plus MB UB, that is this. That is the initial velocities. The initial velocities of both the gun and the bullet is 0. Both of them would have some final value of velocity, which will be given by MAVA plus MBVB. Taking these things further, we can say that twice into VA, because they will not have any initial value of velocity. So if I say the velocity of the gun is VA, so twice, 2 kilograms is the mass, so twice into VA plus MB. MB is equals to 25 grams. So you need to change that into kilograms, so you'll get 0.02 into 125. So solving this out will give you the final answer, that this is going to be the velocity with which the gun is going to be recoiling backwards. Hopefully this was clear. Well students, hope you would have understood and got to know about the topic about conservation of momentum, wherein if you do not have any net external force acting on an object, the object will have the same state of motion. That means the momentum is going to be conserved. So if the objects were at rest, in that case the net momentum initially is going to be 0, and since there is no external force acting, the final momentum as well is going to be 0. This is going to act as well in the case supposing you have a fragment which blasts off. So the fragment is at rest, so initial momentum is going to be 0. The final momentum also is going to be 0, such that the objects fly off in 2 different directions, such that the net momentum even then becomes equals to 0. Hope you understood about this. Stay tuned for more topics.